Just give me a quick minute. Okay, guys. So let's first see what are the course modules. Like what will be the subjects that you will learn in this particular session, in this particular classes. Okay. So first thing is about the two basic structural model, which is known as the OHI model, and the second one is the TCP/IP model, which is carrying the most important topics relevant, like the IPs or some protocol-related informations about them. Okay, so that's models are specifically used to define how devices are connected with each other and how they form or how they negotiated information between them by using this model. Okay, so we are starting discussing from these models. Okay, after that we are continuing with our network fundamentals. Okay, after that we are moving forwards the routing part. And the routing part we have to discuss about the basis, the basics of router and the routing protocols. The routing protocols. After that, we have to learn. After that, we have to learn how to take remote access of the router and the different services. Okay, how to take remote access for 1 minute. How to take remote access of the router and also how to configure different services over over the router. Okay, then we are talking about the security purpose of this router, like how packets should filter over the router. That concept is known as the access control list, which is the very most important topic, because this access control list is a very core structural model to filter the traffic. Okay, like this concept is also used over the firewall to filter the traffic. Okay, so that is the very important point. And third thing is about, sorry, the fourth thing is about the network address translations. Okay, like how to map a particular IP to another IP, like how to share our informations from LAN to WAN network or LAN to LAN network. That is should define, or that particular work should done by the network address translation. So we will discuss it over our sessions. Okay, after that we are continuing with also the switching part. And the switching part we also follow the basics of switch and the switching protocols as well. The switching protocols as well. Then we should follow uh, different different securities, uh, different securities criteria over the switch. And the last thing is about the layer 2 security, the layer 2, or which is also known as the port security. Okay, so these are the basic structural models of your in-depth networking course. So we would follow step by step. Okay, so today's we are going to start the topic about the OSI model. Okay, so before I start the session, I want to say something about this OSI model and the TCP/IP model. Okay, so OSI model, we actually in this model or from today's class to some other classes like 1 to 3 classes more, we are continuing this OSI model and TCP/IP model both combined. Okay, why and how that we'll discuss it when I try to explain both these models. Then okay, so let's start the session. So the first thing is about the OSI model. What is OSI model? The OSI model stands for Open System Interconnection. Okay, it stands for Open System Interconnection Model. Interconnection. Actually, OSI model was the first model which is introduced to give the basic idea how devices are connected with each other to form a specific network, and through this network how information should negotiated between them. Okay, but OSI model follows the very basic rules and regulations, and it can also explain all the things properly. But the main thing is that when in the case of implementation, if we try to implement the OSI model in the practical field, at that time OSI model became failed because due to some flaws, OSI model didn't implemented properly. Okay, so what are these flaws? So this flaws is like OSI model does not carry any protocol suite models. Like it can explain all the things properly, but how they should work properly or how they should implement it over the devices, that things on that point of view, OSI model completely failed to explain that things. Okay. After that, after OSI model, there is another agency. Actually, OSI is specially designed by the organization which is known as the ISO. ISO stands for International Organization for Standardization. It is an open organization company which is used to or which is define or which is standardize some specific services or some specific informations globally. Okay, so in ISO through ISO in 1984 OSI model was invented. Okay, so after that there is the another model given by the DoD. DoD stands for the Department of Defense. That model is known as the TCP or IP model. TCP stands for the Transmission Control Protocol, whereas the IP stands for the Internet Protocol. This is the specific model which carries the first IP suite model. Like the flaws that carried by this OSI model should completely explained and completely used in the real field or the real devices scenario by using this TCP or IP model. Okay, so the TCP/IP model is known as the implemented model, whereas the OSI model stands for the reference model. We just follow both the models because through OSI model we can gain the keenful knowledge about the network, like how it is created and how it should managed properly. And through the TCP/IP model, we have to learn how the real thing should work. Okay, so that's why in the theoretical part or in the theoretical module, we should follow the OSI model, whereas in the part of practical scenario or the real field scenario, we have to follow the TCP/IP model. Okay, so what is the purpose of this model? OSI model and the TCP/IP model. What are the purposes about these models? How and why do you need these models? Actually, uh, we connected multiple devices. There is a definition which is used to define the network. Actually, if you try to say network, what does it mean? Okay, so Network simply means that like connection of multiple devices. If you connected more than one devices with each other, that particular things, that particular connection is known as the network. Okay. So if we connected multiple devices, then how this connection should created? Like what are the perspective and what are the rules that the devices should check and create that particular session? That particular information should be given by the OSM. Second thing is about if we connected multiple devices, then the main thing is that to negotiate the main purpose to connecting them is to sharing the information or to sharing the resources between them. Okay, so you consider that that particular point. So how they should negotiated informations between them? If there is a problem or if they are facing some problems, then how to solve them? Okay, what are the solutions to resolve that problems? Okay, so that are the things that completely resolve or that things should how do I say like all these concepts should managed by this OSI model and TCP/IP model. Okay, it can give the brief model like how to connect the devices and how information should negotiated between the devices, and if they found some problems, then how to resolve it. Okay, all the things should managed by the OSI model on the TCP/IP model as well. Okay, that's why we have to read these specific models. Okay, so to doing these things, our OSI model is divided into 7 parts. The first part is the application. Actually, this is not the first part. Actually, this is known as the seventh layer. Okay. First, I write down the layers, and I should explain it. What is the layers and how that particular layer should work. Okay. So, application, presentation, session, transport, network, then data link, and now the physical. Okay, so this is the seventh layers. Actually, to doing all these things and to manage whole network properly, the OSI model is divided into these 7 layers. And here I wrote it in descending order. Like this is the seventh layer, whereas the presentation layer is the sixth layer, and session is the fifth layer, transport is the fourth, network is the third, and the data link is the second, and physical is the first layer. Okay, and I also told you that there is another model which is known as the implemented model named as TCP/IP model. Okay, after TCP/IP model, after OSI model, TCP/IP model was implemented by the DoD, which is known as the Department of Defense, that particular organization, and that particular model can easily follow all the concepts of OSI model, and it also can easily implemented over the devices because the TCP/IP model is the first model which is used to explain the whole protocol suite properly. That's why we implement the TCP/IP model over the devices to create the connection to share information or resources among them. Okay, so if you see, to doing these things, also the TCP/IP model is divided into some layers. What are these layers? So the layers is like 1 minute. Okay. So this layers is like applications. Second thing is about the transport. Then the internet. Then the link layer. So the first TCP/IP model is of 4 layers, where the application layer is the fourth layer, transport layer is the third layer, internet layer is the second layer, and the link layer is the first layer. Okay, what are they? Actually, if you compare this TCP/IP model with the OSI model, then you can see a very similar things. Like these 3 layers of OSI model is combinedly implemented over the TCP/IP model named as application layer. Okay, in TCP/IP model, the first layer, the fourth layer, application layer, should perform these 3 layers task in the single layers. Okay, if you can see in OSI model, the application presentation session, these 3 layers are doing the different types of works. Okay, whereas in TCP/IP model, both are combinedly doing all the things in one layer, which is known as the application layer. Okay, and the fourth layer of OSI model is the transport layer, and that particular layer is also remains same in the TCP/IP model. Third link, the third one is in OSI model, the third layer is about the network layer, whereas in transport layer, sorry, in TCP/IP model, the network layer is remains same, but there is slightly changed by its name, where the name is replaced by the internet. Here is a term that used to identify this network. That name is internet. Okay, and now this in OSI model, there are two specific layers. There is data link layer and physical layer, where the TCP/IP model both are combinedly implemented through one layer, which is known as the link layer. Okay, so the first TCP/IP model was like this. Like here we can see the 4 layers in this TCP/IP model. But nowadays, if you see the TCP/IP model, which is named as the updated TCP/IP model, which is guys, just give me a quick minute.
Mhm.
Hello guys. Guys,
Hello.
actually, yeah, we have a new student here, Emmanuel.
Yes, sir.
Yeah, how are you?
Fine, fine, and you, sir?
Okay, fine. I'm absolutely fine. Thank you. So, Emmanuel, I think you were late today. Okay, so you just follow the recording sessions that I will forward it after the end of the session. Okay,
Okay,
so just stay muted. Whether there is any doubts, then you can unmute yourself and ask me. Okay,
okay, sir.
so let's join the session and restart the session also. Okay,
Okay, okay, no problem, sir.
okay. Thank you.
Yeah.
Stay muted, Emmanuel. Okay. So, okay, so where is the topic? Okay, we are discussing about the updated TCP/IP model. Okay, so the updated TCP/IP model is very similar to its previous model, but there is a slightly change. The fourth thing is about, okay, here is the fourth layer. Fourth, sorry, the layer is like application, then the transport, then here the internet is again renamed as the network layer, and the link layer is again divided into data link and physical. Okay, so nowadays we are having the updated TCP/IP model. 1 minute. Okay, so which is having this. Like this is the fourth layer. One layer. Okay. Second thing is about the third layer. The transport layer is the third layer. Network layer is the second layer. Data link layer is the sorry. This is the fifth layer. Okay. Fifth layer, fourth layer, three layer. The physical layer is the first layer. Okay. Okay. So this is the updated TCP/IP model. Okay, guys. So this is the entire layers of OSI model as well as the TCP/IP model. So we should follow these two models where we're discussing about the OSI model like these 7 layers, and in TCP/IP model we're also discussing about these 5 models, these 5 layers. Okay, if you want to confirm these values, just search over the internet and you can get the best structural model over there, like OSI, OSI model, and the TCP/IP model. Okay, so now you can see this is the model that I already present in front of you. This is the OSI model having 7 layers. The TCP/IP original model was in 4th layer, having 4 layers. But now we are using the updated TCP/IP model where we can get 5 layers. Okay, so this is the basic layer concept about the OSI model and TCP/IP model. Okay, so let's start to explaining what is the purpose of these layers, of these individual layers. Like what is the purpose of application layers, the presentation layers, session layers, and like this. Okay, so I again tell the same thing like I should follow the theoretical model in through OSI model and do the practical or explain the practical things that followed by this OSI, sorry, the TCP or IP model. Okay, that is known as the updated TCP/IP model. Fine. So here I give you some specific model structure or some specific PDF to read the theoretical part, or which is named as the OSI model. Okay, it is the one of the best PDF that I have ever get in my life. Okay, but the words are very simple and it is well explained. Okay, if you try to follow this PDF, then you also go through it. Okay, so the thing is like 1 minute. OSI by router. Here is the model. Okay, so I simply forward this link in the group. Okay, so guys, just copy this link. If someone need to read about the theoretical part or about the OSI model, you should go through this model. Sorry, you simply go through this PDF. It is very helpful. Okay, so let's start about the application layer. Okay, application layer. Okay, so the application layer is the 7th layer of OSI model, whereas the application layer of TCP/IP model is the 5th layer. In the operated TCP/IP model, the application layer is the 5th layer. Okay, but the purpose of this application layer remains same, because in OSI model, the things are done by the application layer, presentation layer, and the session layer. Both these tasks should combinedly performed in one layer, which is known as the application layer in TCP or IP model. Okay, so don't be confused to term like that application presentation system. Actually, these are the individual layers in OSI model, but in TCP/IP model, it is that both three layers can combinedly execute that task in one layer, which is known as application layer. Okay, so I should literally want to describe the theoretical part first. So the main task of application layer is to define the user interface. Like the application layer is used to identify or to providing the user interface. Okay. So here is the term named as user interface. What does it mean? Like user interface, like there is an interface where a user can easily communicate with any device. Okay, that particular interface is known as the user interface. Where if you can see, if okay, here I am using the Windows operating system. Okay, so after starting this window, after turn on my system, Windows takes some particular time, and after some time it will give me this screen, which is another desktop screen. And after getting this screen, if I want to do some task over my system, then I can definitely do these things. Okay, so that particular screen, that particular desktop is known as the user interface, because that is the main thing by which I can easily interact with my device. Okay, so this user interface maybe is of two types. One is GUI, which is known as the graphical user interface, and the second one is the CLI, which is known as the command line interface. Okay, so it is not in the part of these things. Okay, it is just very basic things that I should think it is good to explain it here. That's why I explain it. Okay, but it is not the main task of application layer. Okay, so the main task of application layer is to define the task through this graphical user interface. Like I need the graphical, I need the user interface. What is the purpose of this what is the purpose to get the user interface? Because so the main purpose to get the user interface is to doing some things, like to do some work with over that particular device. Okay, so that things is like if I want to do some work, like if I want to send a mail. Okay, if I want to play some game over my systems. Okay, so there is a these are the specific examples of the work that done by me over my systems day by day. Okay, so to doing this particular things, uh, system should follow some specific protocols or some specific rules. Okay, according to OSI model, application layer, according to OSI model, the application layer is used to define these specific services. Okay, like if I want to share some file from one device to another, to doing these things, in OSI model, the application layer use a specific protocol or some specific rules, which is named as the FTP. Okay, and the second thing is that if I want to share some email, or if I want to do a email to a friend of mine, so that time we are using SMTP maybe. So or you can see the POP3. Okay, if you take another example, like okay, if I want to take the remote access of my device, then you can definitely I can definitely use the telnet or use the SSH. Or if I want to access any web services, then at that time I have definitely use some HTTP or some HTTPS things. Okay, so these are the specific services or specific rules that we should follow if we try to do some task over the system. Like when you are using the after getting the user interface, when we want to do some task as per the OSI model concept, this application layer is helping ourselves to providing these particular protocols by which we can able to do this task. Okay, whereas the TCP/IP model exactly explaining the same, but here is a little bit change. Like in TCP/IP model, that particular model rectify that particular things, like these are not the protocols, these are the services which are used to execute the whole process. Okay, it is not like if I try to do a task like okay, if you can see, if I want to do an image, if I want to draw an image here, okay, so I choose lot of tools available in this home tab. Okay, different shapes, different colors. And the if I try to put some colors like some clear type colors or brushes, so there are various types of colors. Okay, so by using these specifications, if I draw a image, okay, so the main thing, the main task is to draw an image. But using these tools, that thing should properly done by me. So these are the specific services. These are not the specific protocols by which we should do the things. Okay. Actually, that things is very similar because that particular services should manage by the rules. Okay. That thing should explain by the OSI. Okay. But in TCP/IP model says the same things like these are the services. Okay. And the application layer and the application layer of TCP/IP model is used to identify or to define that particular services. Okay, like if you can see, today we are using the devices which are multitasking in nature. Multitasking means in a particular time our system can able to do more than one task. Okay, more than one task. So if you can see, to doing a single task, if our system needs some multiple services, then if it is multitasking tab, it can definitely be able to do more than one task. And to doing this more than one task, they are using a lot of services. Okay, so to manage this particular services in TCP/IP model, these services should arranged should arranged or should bind with a logical numbers. Like for FTP, we are using a number which is named as the 20 and 21. And you can see for telnet the number is 23, for SSH the number is 22, for POP3 it is 110, for SMTP it is 25, for HTTP it is 8, HTTPS it is 443. So these are the logical numbers which is used to identify some specific services. Okay, so that particular numbers which are used to identify or to define the specific services, that particular numbers, these numbers are known as port numbers. Okay, so port numbers. So what is the proper definition of port numbers? So I can write it here. What is port numbers? Okay, the logical numbers, the logical numbers which are used to define or used to specify a service. The logical numbers which are used to specify services services are known as port numbers. Okay, so this is the main concept. Like in TCP/IP model, all the services should managed in a particular manner, and that manner is named as port numbers. Okay, and this port number is of 16 bits. Okay, so I also write the same things here. It is of 16 bits. If you can see, it is 16 bits. If you describe it in decimal, so the range is belonging from 2 to the power 16 to raised to the power 16, and which is equals to 65536. Okay, so in this binary number system, the calculation process should start by 0, and the range is from 0 to 65535. Okay, zero is reserved for the self, like devices use this zero to zero for itself, like to identify the specific services easily. Okay, and the specific range is from 1 to 65535. Okay, and that particular range is divided into two types. Okay, so I simply draw this diagram where is you can get the proper idea about the port numbers. So port numbers is about 1 to 65535. Actually, this is the specific range which are used to that particular range is used to identify the port numbers. Okay, and that particular port numbers range is divided into two parts. First one is the well-known port number range, the well-known port numbers range, which are 1 to 1023. Like in this range, like 1 to 1023, if you choose any number, if you choose any number within this range from 1 to 1023, then you can get a specific service bind with that particular number. Like if you choose 40, sorry, if you choose 80, then there is a service which is named as HTTP. If you choose 23, then there is a service which is used to take the remote access named as Telnet. So if you choose any number within this range, you can definitely get a specific service bind with that particular number. That's why it is named as the well-known port numbers. Okay. Okay. So 1 minute. I think my handwriting is not well. I have to write it clearly. Well-known port numbers. The range is from 1 to 1023. Okay. So the second thing is about the range from. It is named as the dynamic port range. Dynamic port range. Dynamic port number. Dynamic port numbers. Okay, which is again divided into two types. Divided into two parts. Where the first part is known as the registered port number. The registered port numbers. The range is from 10242 49151. And second part is used for uh, the private port numbers. The okay, 1 minute, sorry. Port numbers, the range is from 491522 65535. Okay, so this is the classification of the port numbers according to the use, according to the uses. Okay, so let try to explain it. What is the need to define the port numbers? Try to define the services by using these logical numbers. And what are the main concept to put the port numbers into this scenario? Okay, so let's start discussing about it. Like if you see, I have a server. Okay, 1 minute. Okay, so you can see here is a server, and I love to watch the cartoon movies. Okay, so one of them is available over this server. Okay, and I need to watch it now. So to doing these things, I have to download the movies through this server to my system. Then I'm able to watch that particular movie. Okay. So to doing these things, I use a specific service named as Telnet. That means I take the remote access of this server, and after that, I can able to download this particular movie from server to my system, and then after I will able to watch this movie. Okay. So to doing these things, I first generate a request to towards the server. Okay, where I have to define what is the service or which type of service that I requested through the server. Okay, so to doing these things, I put a destination field which is used to define the services, and here you can see I am simply define the number 23. Okay, so here is the questions like, if I try to access, if I try to gain some specific services access, then I definitely use that specific service name also. Like instead of 23, if I tried telnet, then server check the telnet, and if the particular service is available over the system, then it can definitely provided me. Okay, so what is the purpose to implement in 23 instead of telnet? Just you can see one thing. If I write telnet, okay, and we also all know, like our systems understanding only one language, which is known as the binary language. Okay, so if you take the telnet as a character value, then the telnet is of 6 words. So our system first converted these character values into decimal values by using the ASCII code. Okay. After that, now my system should get 6 decimal values, and now it again converted these decimal values into binary form to understand that what is the actual request, what is the actual purpose of this specific request. Okay, so to do these things, you can see our system should follow two process, and the conversion process is extremely lengthy. And when it again try to reply me, when it trying to reply me, then it also doing the same things, which is also a very lengthy process. So if I use the direct name to identify to identify the specific service, then the negotiation of information uh, the negotiation of information is going slower, because every time it's simply used to identify, every time it is used this process to identify what is the purpose of this connection. That's why it taking some time, and by this the whole process is getting slower. Okay, but you can see if I using 23 instead of telnet, then server receive the port number which is 23, and again 23 they convert it into binary form. To convert 23 into binary form, it is a very fast process for system, because if you can see, if I try to explain it, okay, so I can definitely use like this 11101. So this is the binary form of 23. Okay, so for me it is less than 2 seconds of systems which is literally have that much of ability to process or to compute this logical value. Then that process is a very rapid, or it is executed a fraction of seconds, a fraction of milliseconds, less than 1 seconds. Okay, so the so it can simply convert this 23 into binary form, and it can able to understand what is the purpose of this particular request. Okay, you just check the library and you can know that 23 is a number which is used to identify, or 23 is used to specify a specific service named as telnet. Okay, so you can see that there is a PC which is trying to make or requesting for a telnet service to me. Then it simply understand these things, and it simply, if that specific service is available over this server, then it simply reply back to me to give the access of this remote connection, and now I'm able to download that particular movie to my system, and now after getting the movie I am able to see the movie. Okay, so this is the main purpose to don't use the whole name. Actually, this is the main purpose to use logical number, so the logical name instead of the whole name to identify or to specify the specific service. Okay. So, guys, till now everything is understandable, or there is some doubts in your mind. Hello, guys, am I audible?
Yes, yeah.
Yeah, everything is clear, or there is some doubts.
Yeah, it's clear, but I didn't get to about the telnet part little bit. Like,
Oh, telnet back. Actually,
yeah.
telnet is a character. It is a word that formed combination of
Okay.
characters. Okay.
Okay.
So if you requested the specific service by using this telnet, which is a word, then to understand that specific word, what is the purpose of this word telnet. So the system follow this specific conversion process. Like it simply follow the ASCII code to identify what is the decimal values of this telnet character. It choose for system the telnet is simply the characters, which is mean that TELNET. Okay,
Okay.
this is the
Okay.
six
Got it.
characters which is
Yeah.
used to define something. Okay, so it
Okay. Okay.
simply convert that values into binary and again convert it to the decimal form, sorry, to the binary form to understand what is the purpose of this word telnet. Okay,
Okay. Okay.
so to
Got it.
converting process is a very lengthy process. That's why we are using the port number instead of the whole name.
Okay.
Is it
Okay.
clear
Got it.
now?
Yes. Yes. Yeah. I got
Okay.
it.
Okay, thank you.
Yeah. Thank you very much.
So guys, just give me some quick minutes. Okay, I have to go to washroom. Actually, I get a nature calling. Okay, 1 minute. Just. Okay, sorry guys. Let's start the session again. Okay, the recording is on. It's fine. Okay, so this is the main purpose to define. Okay, so this is the main purpose to implementing the port numbers instead of using the whole name to identify the specific service. Okay, so now we have to see what is the main what is the main task to perform by the application here. Okay, So again, reuse the same example. Okay. So let's see. Uh, Here is the server. Okay. Here is the server. Okay. Here is the PCA, and here is the PC named as PCB. Here is the PC named as PCC. Okay. Uh, okay. So you can see PCA wants to download some information or wants to download. Sorry, this PCA wants to download some movies through this particular server. Okay. To doing these things, if PCA send a telnet request to the server. Okay. So the destination number is the destination port number is 23. Okay. So if the specifics request uh, received by the specific server, then server immediately make an entry. Okay, like this. Destination port number is 23. Okay, and the specific purpose is the movie. Just take an example. Okay, for understandable purpose. Okay, actually this is not the actual model. Okay, it is just used it is just I explaining to understanding all the concepts, all the processes should done by the application layer. Okay. Okay, if you can see at the same time when PCA requested for the telnet request or the telnet access of the server, at the same time PCB also wants to listening to the music. Okay, at the same time PCB wants to listen some music from the server and is again doing the same request to the server, like it is also requesting for the telnet to download some music and listen that. So to do these things, server again receive the port number 23, purpose song. Okay. If you can see it is a PCC, again it is also requesting for the same service which is named as 23, and the purpose is to do a email. Okay. So you can see in a in this server, the server is receiving three requests. Okay, where all the destination port number is totally same. Okay, so when okay, these things is not that much of confusing for the server, but the main thing is that when the server is starting replying, when the particular server is starting reply to this specific request, then the server will be confused. Why? Because the port numbers are remain same. The request port numbers over the server is remain same, but the purpose is different. So the server is getting little bit confused for which PC sends which service request. Okay, so to get or to deliver all the things, all the requests properly, create this table by arranging in this way. Like here is three fields. One is the destination port field, which is remain the same, and here is the another field which is known as the source port numbers. Like if the PCA requested for telnet, that it is also using a source port number to unique identify itself. It is the range or it is the number which is randomly taken by any device through this particular range, which is known as the dynamic port number range, which is from 1024 to 65535. Okay, so you can see that. So you can consider like this port, this PCA may choose 1024 for its unique identification or as its source port number. Like this is the 1024 port number. Okay. So if PCB requested for telnet by taking the source port number as 1024, then when server started creating the table and you can see it is the 24, then it simply check that this 24, this source port number value is already exist in this particular table. So it simply discard this packet, simply discard this specific request and send a message to this particular system. Like it simply send a message to PCB like you just modify some configurations in between this packet and try to resend this connection to me. Okay, so at that time the PCB modify its source port number as different port number and again requested to the server. And servers check that the port number is 1025, which is not available over this tabulation process, or this so that particular port number is not available in its own table. That's why it's simply recorded as 223 and the source port number is 1025. And for PCC, if the PCC using 1024 or 1025, it simply discard the packet. And here PCB use some different values to unique identify itself. Like it can be used 1026. Now at the time of replying, the server doesn't get confused because now it has some specific port numbers which are used to unique identify a particular system. Okay, so that thing should managed by the application layer. In TCP/IP model, application layer is used to identify or to providing or to unify the specific services. Okay, so that is the main things which is done by the application layer in transport. Okay, so guys, till now any doubts? Hello, hello guys. Hello
Yes, hello, sir.
guys, am I audible?
Yes, 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 sir.
Yeah. Guys, do you have any doubts till now?
No, no, it is well explained according to me.
Yes. Yes, Emmanuel.
I'm saying that it is well explained according to me, so no doubt for now, no question.
Okay, thank you very much.
Okay.
Okay, so any other guys have some doubts?
No, no,
Adamo,
no. It's
Joel,
okay.
Srikant, it's okay, fine. Joy, Srikant, okay. So let's continue.